Last time we learned how to record measurements to the correct number of significant digits, properly reading measurement devices. Now what we're going to learn how to do is interpret the number of significant digits when a measurement is recorded to you. That is important because we need to understand the recording of those measurements in order to do calculations. So let's take a look at how this goes. There are 5 rules for determining the number of significant digits in a measurement. And we'll go through them all together here. Here we go. 1. All non-zeros are significant. You wouldn't write a number down unless you were somehow pulling it off the measurement scale that you were reading. So here we have 12,345 centimeters. That has 5 significant digits, and the 5 is the estimated digit. Means your uncertainty on this measuring device is in the ones place. Rule number 2. Zeros between non-zeros are significant. So any zeros sandwiched between non-zero numbers, any number of zeros, we could have 5 zeros in here between the 3 and the 4, they would all be considered significant. You would not pull that 0 off between the 3 and the 4 unless you were pulling it directly off a scale. So this is 123,045 centimeters. That has 6 significant digits, and the 5 is the estimated digit. Leading zeros are never significant. Zeros that come before a number. That doesn't matter whether or not there's a decimal point. And if you think about this without a decimal point, like if I had 54 kilograms, there would be no meaning or change to the number if I wrote 0.54 kilograms and there was no decimal point involved anywhere there. The zeros would not provide any additional meaning. Now, this is the part that really confuses people, because do not confuse the idea of significant with important. Those zeros are important for communicating the size of that measurement. They are not significant because they don't tell us about the sensitivity of the scale. And if I convert this from centimeters to millimeters, I get 0.0123. One of those zeros is going to disappear because a millimeter is a smaller unit than a centimeter is. And you shouldn't change the sensitivity of your measuring device just because you've done a unit conversion. You haven't gotten a new measuring device. You haven't retaken the measurement. You haven't done anything than a little bit of math and some, factor of 10 conversion there. So zeros before the number are sometimes placeholders and decimals, but they are not significant in terms of numbers recorded off of a particular measuring scale. So 0.00123 would have 3 significant digits, and the last digit there, the third digit, is your estimated digit. All right, so here's the rule that's hard. Trailing zeros are sometimes significant. Trailing zeros, like leading zeros, could be placeholders, but they could also be significant in the measurement, and it's up to you as the writer of the measurement to communicate that. Zeros after the number only count as significant if there's a decimal point. We all learned in elementary school that the decimal point goes at the end of a standard number. That's not what I mean. Every number essentially has a decimal point, whether we write it or not. When I say trailing zeros are only important if there's a decimal point, I mean if there is ink or pixel on the page or the screen. You have to actually see that dot to count the zeros. So 12,300 meters has 3 significant digits. These last 2 digits are considered not significant. What that tells you is that the 3 there has to be your estimated digit, and your uncertainty is in the hundreds place. That measurement is 12,300 plus or minus a couple of hundred meters. Turns out that's not a very good measurement. If we drop the 0 down on the screen, now those zeros count as significant. And there are 5 significant digits in that measurement, and my uncertainty is in the ones place. That's 12,300 plus or minus a couple of meters. So even though these are the same number, they are drastically different measurements in terms of our uncertainty. Now, what if you want to count some zeros but not other zeros? The trick that we use is we put a bar over the zeros we intend to count. That bar says count this 0 as significant, and by the way, any other zeros to the left of that bar would count as significant. We don't have any in this number, but we could. But the difference here now is this is 12,300. My estimated digit is in the tens place, so I'm saying plus or minus 10 or 20 meters. So again, all of these are the same number, but they are different measurement sensitivities. Plus or minus 100, plus or minus 1, plus or minus 10, right? The last thing that you can do to determine what zeros to count or not count is put numbers into scientific notation. Scientific notation, again, is a number and a power of 10. This number will always be between 1 and 10. And so there will always be a decimal. So the zeros I intend to count as significant are always included in the scientific notation, and the ones I don't count as significant. So look at that fourth measurement on step number 4 there. That fourth measurement is identical to one of the 3 that precedes it. Pause the video, give it a thought, maybe circle one in your notes. Okay, if you didn't circle one in your notes, then you should really think about pausing again and doing that. It forces you to commit to thinking about an idea and not just waiting for me to explain it. You have to engage your own brains here, but if 1 0 is considered significant, that last 0 is always our estimated digit. We need to find which one of these has that same 0 after the 3 is estimated. And it turns out it's this measurement right here with the bar. So the last 2 measurements here are identical measurements. They are the same. They are different ways to write the same measurement. All right, my last rule. Counting numbers are non-measurements. They have an infinite number of significant digits. By that I mean there's no estimate, there's no uncertainty when you're counting. Let's say there's 5 marbles on the desk in front of you. If I ask you how many marbles there are, you're not going to go 1, 2, 3, 4.7. No, if you've got 5 marbles, you got 5 marbles, and you are certain of that fact. So to write 5 marbles as a measurement, you would have to write 5.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 out into infinity. That's why we say they have an infinite number of significant figures. And that will become very important when we come around and start talking about calculations. So let's look at some practice. For each of these, you're going to want to stop, pause the video, write an answer, and then play the video to see how well you did. So how many significant figures are in the measurement you see on the screen in front of you? Okay, we have some zeros here. Zeros before the number never count. We don't have zeros before the number. Zeros after the number only count if there is no decimal point. Or sorry, there is a decimal point, and there is no decimal point here, so those zeros don't count. My uncertainty is in the hundreds place. This is a remarkably bad measurement. It's 1,200 plus or minus a couple of hundred meters. That's like you looking out across a field and saying, yeah, I think that tree is about 1,200 meters away. That's how the uncertainty is going to work there. So this would have 2 significant digits. Let's take another one. Pause, jot down your answers. Okay, zeros before the number never count, so we're going to exclude all of these numbers. Zeros after the number only count if there's a decimal point. Do you see a decimal point? Lo and behold, you do. And so we're going to count 1, 2, 3, 4 significant digits, and that last 0 is my estimated digit. Oh, how sad it is that we're not even going to get even close to this year. But we all, I think, probably remember 2015 and what a joy it was. So 12 Royals playoff tickets. How many significant digits? And the answer here is a sideways 8. By that I mean infinity. There's an infinite number of significant digits here. There is 0 uncertainty. You either have 12 tickets or you don't have 12 tickets. If you have part of a ticket, you've got 11 tickets, because half a ticket is not going to get you into a game. So there's an infinite number of significant digits because it's a counting number. Back when the Royals were in the playoffs, I did a little bit of math. Face value of a ticket to go to one of their, I believe it was the World Series games I did this math on. If you were to buy 12 tickets at face value, it would cost you $3,200, or it would have cost you $3,255.67. How many significant digits do you think are in that number? If you also wrote infinity, way to go. We engage in monetary transactions in this country to whole pennies, unless you're talking about like the stock market. But we're talking about buying tickets. If you give them approximately $3,255.67, they're not going to give you the 12 tickets, right? You need to exactly have that amount. This is an exact number of pennies. So just because there's a decimal point doesn't suddenly make this thing a measurement. Okay, we'll give you one more try. So how many significant digits? Well, 1, 2, 3. Zeros after the number count if there's a decimal point. In scientific notation, you only want to focus on the number part, not the power of 10. That's just telling you how big the number is. So that's 3 significant digits. The 0 is the estimated digit. We're going to change the game just a little bit here. Now I want you to round these numbers to 3 significant digits. When I say that, I'm saying start from the left and count over till you get to 3. Look at the next digit and tell me whether I'm going to have to round up or round down. So what you're essentially trying to find is the place value that you need to round off. So I need to round off 1, 2, 3 at the thousands place. And what's the next highest thousand, since we round up because of the 6, from 409,000? So pause the video, write your answer. If you wrote 410,000, you're almost right. So if you're looking at 410, comma 000 on your paper, that only has 2 significant digits, and we said round to 3 significant digits. You're going to need to make sure you put that bar over that 10 that you intend to count. That tells us that our estimation is in the thousands place and not the 10,000s place. The other thing you could do is scientific notation. So if our decimal point is here, we count over 1, 2, 3, 4, 5. You need a number between 1 and 10. I only want 3 significant digits, so I write 4.10 times 10 to the 5th seconds. One more practice at the rounding. So round that to 3 significant digits. You're supposed to be pausing the video right now. Did you pause it? Okay, let's go. If you wrote an answer down, hopefully you did. If you didn't, pause the video and write an answer down. We're going to start from the left and we're going to count over 3 significant digits. Zeros before the number never count, so I have to start here. 1, 2, 3. I look at my next digit, which is a 3. So you need to think, do I round up or down? Well, a 3 is going to tell me to round down. 4 and less, you round down. 5 and more, you round up. So I'm going to cut this number off here. I'm not going to round up. We're going to end up with 0.000143 moles. That will be rounding that to 3 significant digits. All right, we're going to do one more try. Take a look at this number, round it to 3 significant digits, write the correct answer for me. First thing you might have done is you might have considered how many significant digits we currently have. Zeros after the number only count if there's a decimal point, and there is. So the way this number is written, I have to count 1, 2, 3, 4, 5 significant digits, my estimated digits in the ones place. I only want 3. If I take the decimal point away, I'm stuck with only 1 significant digit because zeros after the number only count if there's a decimal point. What do we do when we only want to count some zeros? Well, we put a bar. So you put the bar over the digit you intend to count, which essentially turns that into a non-zero, which means that 0 also counts as significant. So I have 1, 2, 3 significant digits. My estimated digit is in the hundreds place. So that's 40,000 meters plus or minus a couple of hundred meters. Your other option, of course, is to go into scientific notation. That also has 3 significant digits. And that is how we determine the number of significant digits in a measurement.